laptop, local application service is okay. So then you can connect the database. However, as I asked, is required in the project, we are going to use the GCP also. So this part will be moved to the also GCP using compute engine or app engine, either of them. So in case of you are using app engine is all this kind of configuration is already set up, configured. By clicking, and or the developing on the here, you can deploy. Then it will be you don't have to worry about the setup, configure everything. Then you can just focusing on the application. But unfortunately, GCP the limit the languages supported like the Python, Java, C, and Go languages, Google languages, and what else? Node.js. Those are popular, but unfortunately, the ASP.NET, the C# ASP.NET are not supported here. So if in that case, I really like the C# ASP.NET, you can do this one using that, but separately you need to use select any other language that are supported by the GCP and implement separately, two implementation. But it's good for your experience also. So these are the overall thing. That from this week, from now on, what we miss, so database design and database application, database programming part is almost covered. What we miss is this one. So this is what? Don't worry. So far, I have waited for you. So it's a review, the last, the 8 weeks. So this is what? This is our computer, and inside, this is the database management system. So what is the database management system? Is it hardware? No, it's a software. And what kind of software? Is it operating system software? No. No, what is operating system? Anyone who took the exam just before? So what is an operating system? It's a group of software interface between user and the hardware. That means, so sometimes in the broad view, any software that are included when you purchase a computer, then included in the computer, so it can be considered as the operating system. The micro view, the operating system is a kernel. The first program that are loaded when you start up so it's kind of anyway the in between. Without the operating system, you cannot use the hardware. So you do the operating system, you can access that. And the others are considered as the application program, like the code and the compile and make the A.out, the executable part. These are the application program. And the Microsoft Word or the PowerPoint, all of these are application program. What about the database? It's a software, it's not operating system, so we can consider the DBMS as the application program. But it's not the clear or the confident to say the database management system is just the application program. Is this same level as the Microsoft Word or the Excel file? Excel? It looks like there's something different. Okay, that's true. So DBMS is actually, for example, it manages its own memory. For example, what is throughout the long history of it's not that long, like the 60, 70, 80 years old. What is the first computer? What is the computer? Pentium? Vacuum tube. So using vacuum tube, you probably heard about ENIAC or the similar name of that. It's like the 1940 something, the UPenn and the Iowa, so such the department developed the first computer system at the time. From that, since the first computer, we encounter always, why do you use the computer? What is a computer, by the way? Compute something. It's a person who compute. Teacher is a person who teach. but it's not person, it's a machine. Okay, with the power, electric device to compute. That's true. Computer compute something. That's the main job. Because of that, we have the CPU, Central Processing Unit. What is the main job of the CPU?
Process.
It's a computer. Process what? Instruction level. That instruction is nothing but computation, like the computation of a binary number. That is on the some of the data registered, but the hardware, in terms of hardware, is implemented, such as the very basic computation operation, like the increment, decrement, shift, or the move. Such operations are implemented in the CPU. CPU focuses on compute. So compute is the main goal. However, not always the CPU or the computer is powerful enough to compute any request. It's slow, mostly. Okay, some of the people still the single processor is not enough. So historically, whenever we encounter such a speed problem, how can we resolve such a speed issue, efficiency issue? How can you speed up computation? Increase the CPU power? What is the stuff? If we have the improvement, we can definitely use. But it's a maximum. It's the fastest CPU. But we need this much fast. How can we address that issue? Parallel processing, but it's not that old. Okay? So recently, still the parallel processing, there are a lot of issues. So parallel processing is one of the way, not always. So computer science, computer engineering, any computer stuff use cache. So cache is one of the, think about why do we need the memory? We have a storage, but we have another memory storage. Why? Because the hard disk drives, SSD, such a storage, primary storage is not fast enough to support the CPU request. So not only we don't have to put all the data in the hard disk drive to the memory. Instead, some of the data, because memory is a faster device. So that we keep the frequently accessed data in the memory. Okay? Frequently access the program in the memory. Okay? So that is the cache. So cache is the faster in-between device. Okay? That can be reused. Okay, reuse. So cache is the really convenient way to speed up, like the add to cache in the CPU. Even the memory is not fast enough, so we keep some of the cache data in the CPU chip, which is called the add to cache, like the 4 megabyte, 8 megabyte. Nowadays, what is the general size of the add to cache? 16? 16? The bigger is the better? Yes, the bigger is the better, not always. If you have the 1 gigabyte add to cache, it will be overhead to manage the cache memory. Okay? There are some algorithms that we will discuss later, but what about the database? Database also encounters such a speed issue. A lot of data are in the hard disk drive, storage. Okay? Especially the relational database use huge. Like nowadays it's a petabyte size level. What is a petabyte? What is the size of your hard disk drive on your laptop?
1 terabyte.
1 terabyte. How many of them do you need? Thousands of them. It will be the petabyte size. Several petabyte size. This is huge. Memory size? What is the memory size?
8 GB.
It's 8 gigabyte?
Yes.
It's pretty much you're so rich. 8 gigabyte. The memory. Okay? So that's not enough. So database use the memory area and also reserve. Let's say we have the 8 gigabyte of memory, but 4 gigabyte I'd like to reserve the area only for database. Okay? Only for database the student can use the table. The others can be shared by any UB student. Then we can speed up to support the database. Okay? Similarly, when you start up any DBMS, any database, they reserve the certain amount of memory and directly access this memory area as a cache. Which means which part of the computer component do the same thing, operating system. So if you are taking the operating system class, the next subject will be memory management. Because the memory is a fast device, but it's not big enough. So we need to manage the smartly. So that will be happen, exactly same thing happen, DBMS. So DBMS also, somebody said, this job is the main job of the operating system. So it's not just application level, it's kind of in between application and operating system. So this is the funny thing happened several years ago. The Oracle actually would like to develop, they developed the database operating system. So if you join the database project after graduation, most of the system has database server, which means the computer or server is dedicated to the database only. No other application, no other thing. It's just for the database, which means database is, so it's a general. The IT department, any project, they assign one, even very fast, very expensive, high-end computer for the database server. Because database is important to access the data very fast. Which means Oracle realized, even though your project is very expensive, the operating system, for example, we do not use all of that. It's something bothering. Because can we include operating system part into the database? Because database, this is just one example. Even sometimes database management system directly access the hard disk drive, I/O management. And also create the process, some process management done. So Oracle thought, why don't we include operating system as a part of database management system? That happened. Was it success or not? It's a failure. Because anyway, Oracle, the DBMS is on top of operating system. If they combine, so a lot of overhead to manage the operating system part. So they cannot, the user do not like such an architecture, so nobody use such the operating system side, the DBMS, then the Oracle later developed. But the key part is the DBMS is also system level, such an operating system level operation are doing, which means this is inside the DBMS. It's not like the application program. It's more like should be managed or you need to understand. So from this, today's lecture, we are going to see what's going on inside this DBMS database algorithm. So first thing we are going to see is anyway, this part, even though DBMS use a lot of the computer research, which means, so as I keep saying, anything so that I'm asking or I'm going to ask in this class can be answered, data structure, which means the hardware part is also based on the data structure. To understand that this DBMS, we are going to start to understand the data structure used in the DBMS. Okay? Then, so that is the file, the data structure and so on. Plus, next class we will see. So for example, I probably gave the example of this one. When I travel to the Manhattan from the Bridgeport, how many different ways? Not infinite, there might be the finite cases, but a lot. So we cannot count. But depending on your situation, I need cheapest one. I need the fastest one. I need the convenient one. So each of them has, but let's say the fastest, the route. So among the bunch of different cases like the driving a car, and also the MTA, train, or walk, or the bicycling and motor bicycle, and among the such a possible way to travel to the Manhattan, I'd like to select one fastest way. Okay, how can you judge fastest? You can measure how long it takes to, in case I travel with the MTA, I travel with the airplane, and so on. Okay, then select one of the fastest way to go to Manhattan for your interview. Similarly, database has a lot of tables inside. Like this is employee, this is a department, this is a S. When we access the data, not always we are going to access one table, but also sometimes, most of the cases, we access several tables. We do what kind of operation? Join operation. We can combine 2 tables, 3 tables, and the n number of tables, the easily join operation, which means we need to go to this table, then next to this one, and next to this one. As if when I contact the student, some of the E student here, the CSE student here, the another room is the other student. So when I contact the student, there are different ways. So depending on how to visit such a table, there are a bunch of different ways. So we need to select one fastest way. That is called the query optimization. Query optimization is one of the critical part of the database management system. So each of the DBMS vendor, they do not release the core part of this one. It's kind of top secret. It's the most intelligent part of the database system. So we are going to see what is the general method and the approach to optimize our query. So it's sometimes called the query processing. The query processor includes the query optimizer. We will see such a thing. Then plus, how many users are accessing this DBMS? How many? Many users. So long time ago, actually, the SQL Server, Micro SQL Server used. Think about the Windows 95 or 3.1. Anyone who used the 3.1? Probably not. So if there is, so you are so old. And what about the 95? There are some, probably. Really? There is no one who ever used the 95? 98. Yeah. Then, which means you are around 30 years old, 30-something years old. No? But you use so ME, then the 2000 and so on. So actually up to the Windows 98 is for the single user. Think about how the Windows has been developed. The Bill Gates started the first operating system from his drive, right? By combining MS-DOS. The DOS is the old fact. Then add something like the revolutionary idea of the interface Windows add, then 3.1, and it's really sharp, and it's ever still you are using the Windows from the point of perspective. Okay, then problem is only for the single user like the MS-DOS, but nowadays it's all computer are connected. Okay, then when Microsoft developed the database like the Access and the SQL Server, is all because the operating system is a single user system, so they don't need the multi-user, multi-transaction for the database. It's only the user who are using operating system will use database. So SQL Server was the only single user system. If you have the single user, is it complicated or very simple? It's really simple because it's a single user. You don't have to worry about if you already took the synchronized operating system, synchronization problem. What is a synchronization problem? When you have shared data and you have a multiple process, they are accessing the same data. We cannot guarantee the output. We need to synchronize. However, if you have the one process, which means if you have one user, is there any issue to update or delete and whatever you want to do? No problem. It's very simple. So all the DBMS, even there's a single user system, for example, Microsoft SQL Server was the single user system, no transaction module. So you don't have to worry about any racing issue, any computation to access the data. No log, it's okay because it's all mine. Unfortunately, the Windows changed from single user system to the multi-user system. That is the anti-server. Okay, starting from so Windows decide, Microsoft decide to support the multi-user system transaction. How they separate the one is the single user personal purpose, another one is the anti-server. Then eventually this one is gone, and nowadays the Windows. What is the current one? 10. 8, 10, 7, all these are the based on anti-server, which means you can actually, I can log on just like what you are doing with the Linux and Unix system. I can log on your, it's not only single user, but the most of case, personal purpose is used like the single user operating system. What is a multi-user? So to support to that, actually Microsoft purchased both the transaction module from the Sybase. So Sybase, the transaction module is the same. It's used for the currently the SQL Server. That is the transaction management. Also, when I joined the my first job was the database administrator. So the supervisor, he selected pick me up due to the major, because my undergraduate major was mathematics. Even though I didn't have any background in computer science, I was selected, and I learned a lot through the relational model and the database and so on in-house, not in the classroom. I never took the database class actually. So I learned from the manager. It's kind of in-house. Some of the, if you go back to the record the old tradition, it's not all the skill or the tradition are from the school system, but it's just inherit from the teacher or you're the manager to the only one or two. Similarly, I learned the database and even operating system. I didn't take any operating system. I took the distributed operating system one time. So, but anyway, so when I learned such a thing from the manager, he mentioned about the two things as an administrator. So administrator, the most important part, actually 49% of the database administrator job should be the backup and recovery. Not the system program is also important, and also what else? Your skill, everything is important, but the most important part is the backup and recovery. Because in case something happens, management is anyway the main job of the administrator is management. So which means your system should be stable and without any stopping. But you cannot avoid such the error like what if the 9/11, even though you have the perfect system, if the operating system room is crashed by the airplane like the 9/11, no other way. But in that case, even though we need to recover our system, at that time we need the backup and recovery. It's you probably, if you are interested in the administrator job, like the Unix system administrator, it's the same thing, backup and recovery. There's another important one, 51%. So really most important job of the
Designer?
administrator.
Database designer?
You can hire the designer. That is documentation. So documentation is the most, because actually I'm hired. Who knows, I will be fired tomorrow. But the job should be continued. To do that, documentation is the only, whatever that happen, you can mistake or you can do something like that, it should be documented. So documentation is another important thing. The most important things, but anyway, I'm not going to teach you documentation, but the backup and recovery is also another important part of that. Plus several other components used in the DBMS. We are going to talk about the rest of the semester. Okay, actually, we combine this is undergraduate level, the database course. This is a graduate level database course. So this is a database design. Only teaching database design, which means we complete this part. Then followed by the 551, the advanced database design. We'll discuss mostly this part. But right now they are closely listed. We do not have the many undergraduate students. So I'm teaching this part. It's 60%, 55 to 60%. This is the 40 to 45%. That doesn't mean I can ignore some of the topic. I will try my best to cover this topic. Also, when I taught separately, in this class I offered a project to develop the DBMS, Relational Database Management System. Let me show you the one example of them. I'm not sure I can find it quickly. So, yes, it's several 5 years, 6 years ago. So this is one of the screenshots that we developed in the classroom. It's called the UBDB. So it's a database is based on the SQL 2 standard, and you can see you can create a database. Its name is the B database. Okay, then we connect the B database and using database. It's similar as the MySQL at the start. And we can create the table. At that time, we didn't have enough time to create the index. It's only the table part. And for the table, we can create. So, for example, student. And two main types of the data type. So, the integer and the string. So, we simplify them. And we can insert. At that time, we followed the SQL 2 standard to very simplify. So, but if we can add the query, no query optimized transaction managed single user system, so we can add it. That was done in when we separate. But we cannot do this one. But if you are interested in the project, like the master level project, you can do. Then finally, we can, after we insert the data, we can select from the student and so on. Okay, so let's just click. So today we are going to start from this part. Where is that? The data structure of the database. Okay, if you are asked to develop such a DBMS system. Developing DBMS is much easier than the operating system. Operating system, you need to know the standard or input and output definition of you need to know the IEEE standard and what is for example, the HMI. So you need to build all such the device program and so on. Okay, and also kernel program. For the kernel program, you should know the hardware part, the CPU, and even the different CPU you need to. But the database management system is much easier than that. On top of the operating system, which means you can use the system library. So if you need to access the memory directly, you can use the malloc, for example. You can allocate the specific memory area, then you can use that memory area for the database cache. Okay, so something like that. So it's much easier and much more fun. Because of that, you can find a lot of such as the sample DBMS from the website. Many of them are educational purpose. Even some of it's less and less. The university offer the database project to develop the DBMS, but it's much more fun to develop. But suppose that you are asked to develop the DBMS, especially relational database management system. So how can you start? What do you guys need to do? What do you need to know? What do you need to have?
Problem statement.
Problem?
Problem statement.
Problem. So what kind of problem? So you can define. So what is the most, I think there's still running one. I need to close. Okay, so to define the problem, what kind of problem you can define? when you develop the DBMS. It's not mine. So actually the student who left, but it looks like his girlfriend. Okay, so what kind of the problem? You can think about the first how to implement the SQL, right? But think about the SQL is the language. So if you have the experience on compiler, unfortunately UB does not offer the compiler, but which is very, very critical course to understand the overall computer system and computer language, and in between. The compiler is one of the best way to understand such a thing. But if you have the compiler, if you know the compiler, we can, even the SQL is much, much easier than the other program languages. Okay? Like the keyword is very clear, select. Okay? You can use the lexical analysis, not complicated than the C language or C++. If you do not know what is a lexical analysis or abstraction, please take a look at least the Wikipedia and search the Wikipedia, and for the compiler you can understand such a thing. So language SQL part is not very complicated. And what else do you need to have? This kind of component that I explained. Then first when I'd like to use the database to store the data and to access the data, which means there should be what? Memory first. Even without memory, we can implement it. Actually, the UBDB, we didn't consider memory management because it's the next step. You need to have the storage to create the table and to store the data. Then finally, you can able to access the data using the SQL. Then, what kind of storage you can imagine? If you create the table, what kind of storage are you going to use?
Depends on
Yeah, so for example, it depends on the variety of the situation. What kind of example of the storage of your database?
Any persistent hard drive.
Process.
Persistent.
Persistent, which means hard disk drive. For the hard disk drive, how can you use the hard disk drive for your storage? RAM, but he is a different media. So first talk about the persistent storage. How can you use the persistent storage?
Through I/O.
Through the I/O device, but for example, if I'm asking to store the list of students on your laptop with the C programming or Java programming, how can you keep such a student information?
Data structure.
Data structure. Then we are talking about the media. So you are saying the persistent disk, like the hard disk drive. How can you use a hard disk drive to keep such a data? You can create file. This is everybody knows. So you can create a file. Okay. So first approach, when people develop the first relational database management system, they